Hello class, welcome to this video on lesson 2.3. So we're going to cover the homework problems from Canvas, the practice quiz for the 2.3. Now this lesson was about correlation, so it's all about correlation coefficients and more association stuff for scatter plots. So let's go ahead and get started. So the first question, the correlation coefficient is negative. This means that as the value of the explanatory blank, then the value of the response variable, and then fill in the blank. So basically, if the correlation, remember the correlation coefficient is R, and if that's negative, which means it's less than 0, so for example, negative 0.5, what that means, well, that basically means that this is X, this is Y, right? So if it's negative, that means it's going down, right? Like this. So as the X increases, it looks like the Y decreases, right? And as the y increases, the x decreases, right? So you can kind of think of it that way. So basically, following the line, if I go to the right, then it goes down. If I go to the left, then it goes up. And so you see here, this means that as the value of the explanatory variable is x, right? In this case, the response variable is y. So as the explanatory variable increases, then the value of the response variable increases. That's not correct. If as the value of the x variable stays constant, no, that's not correct. So as the explanatory variable decreases, the y decreases. No. As the x decreases, the y increases. Let's see if that's true. As the x decreases, the y increases. That is true. Let me put this in two different colors. That relates to that. And this relates to that. Okay. So that looks true based off what we said. As the x increases, the y stays constant. That's not true. As the x decreases, the y stays constant. No. As the x stays constant, y decreases. No. As the x increases, the y decreases. That is true. As the x increases, the y decreases. All right. The scatter plot for the number of turnovers and the number of points scored for players in the 2013-2014 NBA season is provided below. Estimate the value of the correlation coefficient. Interpret this value. So this looks like a positive pattern, right? And does it look pretty strong? This is what we want to determine. Okay, so here, I went ahead and provided the values for the correlation coefficient that we're going to match it up to. The values from the drop-down menu on Canvas. So the value of the correlation coefficient is roughly, and so definitely, since it's going upward like this, it's definitely a positive relationship. So we're definitely not looking at these, right? So you can eliminate those automatically. And does it look like a strong enough relationship? So based off of this pattern. Okay, so, and the answer is, it looks pretty strong. I mean, like the points are very clustered. Look how close these points are to this line. These points are very close. There's a lot of points here. Look at the cluster of the points. As you go farther away, they veer out a little bit, right? But look at how many points are near this line right here. And so, therefore, I would say that yes, this actually is a pretty strong relationship. So it's definitely not moderate, right? So if we look at this, it's definitely not moderate. It's definitely not weak. So we're going to choose 0.9. If we were to choose 1, it would probably be closer to 0.9 than to anything else. And so we'll go ahead and say that the value of it, if it is roughly 0.9, this means that there's a relationship between the number of points and the number of turnovers. So remember that correlation is for linear relationships, just like this. It looks linear. So this means that the linear relationship between the number of points and the number of turnovers scored for players in the NBA season is, and since we're saying it's 0.9, well, that 0.9 is strong. Is strong and positive relationship. Okay, so next question, the correlation coefficient between ice cream sales and the temperature outside data is 0.9. which implies a strong linear association between the two. This implies that the temperature outside was what caused the change in the ice cream sales. So they're saying that yes, the correlation is very strong. So there is a very strong positive relationship between, the ice cream sales going up, temperature data going up. So they're saying that the temperature, if the temperature were to change, it will cause an increase in ice cream sales. And the answer to that is we can't say that for certain. Right? We can't say that just because they're related to each other doesn't mean that if the temperature outside changed magically for some reason, that it would cause an increase in ice cream sales, because it could decrease, right? It could increase or decrease, right? Or it could stay the same. We can't say for sure because we can't say that the temperature caused the ice cream sales. We can only say that there's a relationship between those two. So this is false. Causation does not, or correlation does not imply causation. Okay, they don't necessarily equal to each other. Okay, so just because they're related doesn't mean that there's a causal relationship. Suppose that a PE teacher collected data about the students in her class. Some of these variables include number of pull-ups, number of push-ups in 1 minute, number of sit-ups in 1 minute, and their weight. Match the relationships with their correlations. So we want to, base off of some common sense and stuff, we want to determine, is there a relationship between these variables? So between the number of pull-ups and the number of push-ups, which one would that look like? Well, I know that as I increase the number of pull-ups, that may correspond to an increase in the number of push-ups, just because both of those are upper body exercises, right? So you would think that if you tone your upper body and you train your upper body, then as long as you train your chest and your every part of your upper body, your chest for push-ups, and then your arms for pull-ups, and your back for pull-ups, then you should be able to do pretty well, right? So there is some kind of relationship between those two. It may not be perfect, but there is some kind of relationship between those. And this is a positive relationship. Now, the number of pull-ups and the number of sit-ups. The number of pull-ups and the number of sit-ups do not seem like they're related to each other. It just doesn't. It might be that for some people, the greater the number of sit-ups, maybe the greater the number of pull-ups, just because they happen to be healthy people, but that might not be the same, or they might be fit, but that might not be true for a lot of people. So yes, this may be I could probably expect it to be a positive relationship, but not a really good one, right? So really weak. I would probably say that this is weak. I would say that this is maybe moderate to strong, compared to the rest of them. The number of pull-ups and the weight. So it looks like the greater your weight, the harder it is to pull yourself up, right? And so I would think that the heavier you are, the less pull-ups you can do. This is not true for everybody, because there are some muscular people that weigh a lot that can do a lot of pull-ups. However, for the majority, I would say an increase in the weight corresponds to a decrease in the number of pull-ups. So this is the first negative relationship that I see. Okay, and so definitely this is going to match up for sure with that. I would say it's moderate, because like I said, there's some people that weigh a lot and they might have more muscle tone. They might be able to pull themselves up. So I'll say this is about moderate. It could be strong depending on, the relationship, but I would say moderate to strong. So clearly that matches up with that. And because we said this is weak, it definitely belongs to 0.3. And then therefore, by default, this would have to go with to the number of pull-ups and the number of push-ups. Okay, so just using a little common sense and then understanding the whole relationship between variables. All right, so match the scatter plot with its corresponding correlation. Type the value of the correlation next to the scatter plot using the values given. I'm just going to match it. I won't type it in. I'll just match it. Okay, so this is a if you look at this scatter plot, well, it looks it's positive for sure. And it doesn't look very strong. So it looks pretty weak. So I would say this is more on the weak side. So probably if it's positive and weak, maybe more like we'll get back to this one because this one may it depends on some of the other ones. So this one right here is definitely negative, and it's not as strong, but it looks stronger than say this one on top. This one's definitely weak. So this is definitely weak. It's definitely weaker than say this one, and it's negative. Okay, so I would probably give this one the this one is weak weaker, but this is the weakest. So I would say this one is probably more on the moderate level. This one's more on the weakest level, the weak. Let's see here. Okay, I forgot to include. I'm missing a value on here that I didn't include. I should have included a value of 0. I just realized. So I got all these values, but 0 should be one of your choices. Here, there doesn't seem to be a clear relationship, so that's probably going to be the 0. So I'm going to match that up right away. This is very strong linear. In fact, it's almost a straight line. So I'm going to say that that's negative 0.99 because that's really, really strong. And this one is pretty strong as well. It's going up and it's pretty strong, but it's not as strong as the one above it. So I'm going to make that, and it's positive. This one's negative, this one's positive. So this one's positive 0.9 probably. Okay, so that matches with that. We got 3 of them matching. We said that this is weak, so we're going to put that under negative 0.3. This one is negative, and it's about moderate strength, I would say. So I would probably match it up with the 0.5, or not the 0.5 because that's it's stronger than 0.5, but it's also negative. So I would probably say it's in the 0.5 to 0.7 range. So I would say 0.7, negative 0.7, and then this one, this moderate strength, it's definitely not 0.1. I would say that's 0.5. Okay, so just based off of comparing it to everybody else, these are the results that you should have. Okay, so notice that there's an extra value there. It's just a distractor value. All right, so the scatter plot for the number of turnovers and a number of points scored for players in the 2013-2014 NBA season is provided below. Which is the explanatory variable? Which is the response variable? So we did this one earlier. We looked at it. It looks pretty good. It's a good, strong relationship. The explanatory variable, we were saying that it was, well, let's see here. We got number of turnovers and number of points scored. So it seems to be that, according to this, the greater the number of, so this is what I'm thinking, the greater the number of turnovers, the greater the number of points, right? Because if you're on a game and you take the ball from the other team, that's a turnover, right? So the greater the number of turnovers that happen, well, then that means you're taking the ball from the team, and then you're probably going to end up scoring more points for your team, right? So the greater the number of turnovers that are advantageous to your team, the greater the number of points your team scores. So I'm thinking that this is probably the explanatory variable. The greater the number of turnovers, the greater the number of points scored. This is the response. It responds to the number of turnovers. So this is going to go on the y-axis, the number of points scored. And this one's going to be the number of turnovers. So the explanatory variable is the number of turnovers because it helps explain changes in the response variable, which is the number of points. All right, do customers who stay longer at buffets give larger tips? Charlotte, a statistics student who happens to work at an Asian buffet, decided to investigate this question for her second semester project. While working as a hostess, she obtained a random number of receipts, which included the length of time and minutes the party was in the restaurant and the amount of the tip in dollars. Here's a scatter plot of these data. So it looks like we're thinking that the greater the time that they spend in the restaurant, the more they tip. It looks like, according to this data, there is a weak positive relationship between those two. It seems that, you know, some of the time, if they spend a longer amount of time in the restaurant, they may tip more, right? They may. But it's a weak relationship because these guys tip more than these guys and they spend less time in the restaurant, right? So this is why this is a weak relationship. But it's still positive. The estimation of the value of the correlation coefficient. So we want to estimate it. I'm going to provide the values for that. All right, so I went ahead and provided the values here from Canvas, so we can select from the choices here. So the estimation of the value of the correlation coefficient. So in this case, the value the value of the correlation coefficient is small. Looks like it would be small because it's really weak, right? This is not a very strong relationship. So I would expect it to be not moderate, not strong, definitely not almost zero. This is like almost non-existent. There is a relationship that exists. That's pretty strong. That's relatively strong, moderate. So I would say it's closer to this one, 0.36. You know, it's weak, but it's not non-existent, right? So I would say it's about 0.36. This means that the linear relationship between the tip and the time correlation is weak and positive. Okay, so looking at the same question, it says, does increasing the amount of time spent in the restaurant cause an increase in the amount of tip? Well, we know that as the time increases, the tip increases, but does that mean that it causes? That means if you were to cause somebody to spend more time on the restaurant, is that going to instantly cause them to increase their tip? Or may not, right? In fact, we can't say that there's a causal relationship between because there are multiple variables at play. What if the person happens to stay longer but they don't order anything else, right? What happens if they're just staying there just to talk to a friend, not really to tip or not really to purchase anything? What happens if someone eats more food than someone else? They might tip more, and the person who doesn't tip more, right? So there are a bunch of variables at play. So this means that even though they're correlated, there is no causal relationship. So an increase in the amount of time a party spends at the restaurant is not likely to cause an increase in the tip. It is likely that both of these variables are changing due to several other variables, such as maybe the amount of food consumed. These other variables that are at play that may impact this relationship, they're known as confounding variables. So the amount of food consumed might be a confounding variable. Maybe there's more drinks involved. If someone drinks, they might be more likely to tip. Who knows, right? So, or maybe they might not be as likely. There are a bunch of variables involved. So in this case, so we're done with all the problems, guys. I hope you took something or learned something from this video. As usual, I'll see you in the next one.